morning, everyone, and then you are most welcome to our 20th Meteorological Virtual Seminar Series, for which we are most grateful to have an honorable member from the Department of Meteorological Science in KNUST to give us a presentation. So we have in the name Dr. Edmond Ilimuan Yamba. Dr. Yamba is a lecturer and a researcher scientist in the Department of Meteorology and Climate Science at Kwame Nkrumah University of Science and Technology, KNUST, Kumasi, Ghana. And he has a core academic training in physics, geophysics, meteorology, and then climate science. And he is an expert in tropical and African climates. He is also an expert in data analysis, mathematical biological modeling in infectious diseases. He is an expert in application of mathematical models for disease surveillance. And then he also uses computer clusters. He is also an expert in climate change and variability, and then also an expert in environmental modeling and then climate projections. So, today, Dr. Yamba is here to present to us on a topic revisiting the agro-climatic zone of Ghana, a reclassification in conformity with climate change and variability. So, without much ado, I have to unshare my screen and then allow Dr. Yamba to take over.
Okay, great. So thank you very much, Osasa, for your introduction. And I also want to thank the organizers for the invitation to join this conversation. And I think today's conversation is going to be exciting because it's going to talk about a topic that we kind of forgotten in quotes. And I use the term forgotten because that's why you find in the presentation topic, you have something like revisiting. So, and it's also a topic, something that all of us are much more interested in, especially those of us into forecasting or agriculture. Of course, I'm going to be doing the presentation, but then I have my other team members who we did this work together. Jeffrey, Sarah, Dr. Kwanzaa, Professor Mikuji, and then the rest. And so I'm sure they are also online, and as and when the questions come, all of us are available to answer. Great. So I'm going to go ahead with the presentation. As you mentioned, my name is Edmond, and I'm affiliated to the Department of Meteorology and Climate Science, KNUST. So in my presentation today, I would try to give you some bit of background on the climate work that we have done and what the motivation was that we had to go in doing that reclassification. Then I will give you some results or take you through some methods, some results, and then some take-home messages that you can think about. And at the end of it all, if there are questions, I'm open to that conversation. We can keep it going. Great. So agro-climatic zone, then agro-ecological zone. I brought these two terms because they kind of look alike, but they are a bit different. And in most cases, sometimes you see people confusing agro-climatic zones with agro-ecological zones. And so if you take, for example, if you agro-climatic zones, for example, refer to geographical areas that are delineated or characterized using similar climatic conditions. And in such cases, you would always depend on temperature, rainfall, humidity, or sometimes they use solar radiation. And the main purpose of delineating or talking about like agro-climatic zone is just to understand the impact of climate on crop growth or crop yield or agricultural practices. But then when you talk about agroecological zones, the focus is more on ecological aspects of agricultural systems. And when you are doing such delineations, you will always use things like soil characteristics, topography, or land cover, or sometimes use talk about biodiversity and water availability. Okay, so that would mean that within one climatic zone, you can have different agroecological zones. So sometimes you can find most zoning, maybe you find, you can sometimes say that an agroecological zone can be a subset of an agro-climatic zone. But the difference is that one is looking at the impact of climate, and so using only climate variable, and one is focused more on agroecological, the ecological aspect. So I remember this argument with one reviewer on this aspect where you're talking about the climate zones, and then the reviewer comes back with comments and wanting you to use like soil types, soil characteristics, biodiversity, and classifying agroclimatic zones. And this is also something that you find most of the time happening, like that people do that. Right. So that's just it. Now, coming back to our main work, what was the motivation? If you look at like on the left side of the presentation, you see, and this is the age-old agroclimatic zones that the Ghana Meteorological Agency classified some years back, I think somewhere in the 60s. Now, when you look at this map has been in use since then. And to date, there hasn't been any changes on that reclassification. So you will see that they had like the north transition forest belt and then the coastal belt. And then all these locations, the names there that you see are some of their, where they have their meteorological stations, measurement stations where they take data. And they use this grouping for most of their forecasting. So if you're familiar to TV weather forecast, you always hear them talk about the north or the transition belt or the coastal belt that way. This is how they divided the geographical space of Ghana into these four main parts. But like I mentioned, this has been in use for a very long time, and there hasn't been any changes to it. And if we're still depending on this, using this classification, then the implication is that the climate of Ghana is stable. In other words, there are no any changes. But the question is, can we really stamp our feet on the ground and say that climate has actually not changed? If it has not changed, then that's okay, we can stay with this. But if it has changed, then it means that we need to do something about the classification. So here, I'm just giving you some evidence that there's some evidence to the fact that climate has changed. And these plots that you see here are also just some excerpts of work that is currently ongoing. And very soon, I think it should be out. And here, we're just trying to quantify the amount of warming. And this is an example for northern Ghana. So if you look at this for minimum temperature, and then if you look at the amount of warming, so I have locations like Boli, Damango, Kitikrachi, Zwaringo, and Wa, and the like. So you see that the data spans all the way from 1980 through to 2020. So if you look at most of these areas, you'll find that the earlier years, as let's say from the 60s, you don't find, you find that there are not much warming. But as you're heading towards 2020, especially from 2000 onwards, you will see that most of those areas have warmed. And in most cases, you find them warming up to about 3 degrees. So if you take a place like Boli, between 2014, 2012 to about 2020, you find a significant warming of about 3 degrees. You can see the same thing in Tamale or in Wa and the like. Another example here is just to show you some trends from Tamale also. And then the right panel is just showing the annual temperature trend. And you could also see that temperatures were quite low from the 60s, but somewhere in the 2000 or upwards, you find the temperatures are quite high. And then the right panel is showing also an example of, again, how much warming has taken place in Tamale itself. Okay, and you could see that right from the 1992 onwards, temperatures have exceeded the threshold, and they are quite warm now. You don't find any colder temperatures anymore. Here is also an example for rainfall. And of course, we can have a more conversation on this one here. And I brought this example because if you see the temporal patterns in rainfall here, you don't see any trends when it comes to rainfall. And I intentionally brought this because you will see sometimes people do research and they will say rainfall is decreasing or is maybe is decreasing or increasing. But from this work, you find that rainfall, especially in the northern region, is just highly variable. So these are evidence to show that climate has changed. And so if climate has changed, then it means that we cannot keep relying on the existing agro-ecological zone map. We will need to reclassify it to conform to current climate change and variability. So here I try to look into what works have been done in this regard. And so I start with you on what the Ghana Meteorological Agency did previously. And on my right, the image that you see, the map that you see is the spatial variations in annual rainfall total over Ghana. And if you look at the classifications that was done by the Ghana Meteorological Agency, they actually use the annual total rainfall to do the classification. So if you would find that if you look at the variations in annual total rainfall, you could see that demarcations look quite similar to what the Ghana Meteorological Agency had done. And so based on this, they're able to tell that, okay, the forest zone is like this, the coastal zone, and you see, especially the coastal zone, you could see that it looks a little bit different and similar to all the classifications that they did. Then you will just find that in my colleague, Jeffrey, built a database, and the database was this observed data, various ground-based meteorological measurements. And all he was trying to do was that most of the data that this observed data that are available are point data, and we don't have them in gridded form. So he tried to rebuild that data, and in testing that data, reclassified the agro-climatic zones, and using the annual rainfall data again. Now, the one issue or problem with using the annual rainfall data is that it has the disadvantage of maxing large areas together as having similar features without taking into account any local variability. So for example, maybe if you want to see any seasonal contrast or dry spell, you will not be able to see that if you're going to use, if you're using annual total rainfall to do that classification. Then recently we have Beside et al. Who also did that classification. And they use humidity, rainfall, they also use maximum and minimum temperature and then relative humidity data to do that classification. Now, one thing we observed about their classification is that most of the data that they used came from, they were point data anyway, and they came from very, okay. So again, I was explaining maybe just a recap, and I was saying that from here, I try to look at previous works that are done and explain that the Ghana Meteorological Agency, when they previously reclassified the geographical space of Ghana into zones, they used the annual rainfall data. And I also talked about my colleague Jeffrey, who also did something trying to validate the data that he built, and did something similar like that using annual total rainfall. And then I was explaining that even though these ideas were good, there's a kind of disadvantage when you are using annual rainfall total, because this annual total rainfall marks usually areas, maybe you can mark a very large area together as having similar features without taking into account any local variability. So for example, if you want to see any seasonal contrast or dry spells, for example, the within seasons, annual total rainfall will not be able to allow you to make that difference. And then recently, BESA et al. Also did some similar classification. And the map that you see here is their zoning. So they classified Ghana into 3 major parts. They called it the savanna, the forest, and then the coastal areas, as you can see from the map here. All right. And they did that using rainfall, maximum and minimum temperature, and relative humidity. Okay. So I kind of like their work, but then looking through it, I saw that there were some shortfalls with it. And one of it was that if you look at one major disadvantage here is data. So most of the data that they used were coming from stations that were not densely spaced throughout all parts of Ghana. So if you look at take the northern part, for example, so you can count up to 1, 2, 3, 4, 5. That's about 5 stations representing the whole of northern Ghana. And then you come to the forest savanna too. Then they also have quite coarse data network there. So that's one challenge with it. And I believe that if they had more data, maybe they would have had a quite good classification. The other problem I saw with it is that, so you can see that almost the northern half of the country, northern Ghana, they've classified it as having one climate zone. And meteorologically, this is problematic because if you look at the extreme ends of northern Ghana, for example, it has a different climate altogether from, let's say, when you are coming to places going to places like Tamale or Boli or Kitekrachi. Those places, their rainfall seasons are kind of quite longer compared to places like Nabrongo or Zwarongo or Boku, especially the extreme ends of the northern Ghana. So to lump all of that area as one climate zone meteorologically is problematic. Then when you come to the forest zone, they also have a very quite large area covering the whole of forest zone. But when you also look at the rainfall distributions, we should have some part of the transition zone, especially areas like Kintampo, Wenchi, and all of those places. They don't have, their rainfall characteristics are slightly different from that of the forest areas like Kumasi, Koforidua, or Sefibekwai, and all those other areas. So it means that those areas too will still need to make some distinctions from that instead of lumping it together as part of the forest belt. And for the, forest belt, okay. So these were the challenges that I saw with that classification from BESA et al. So what's our main objective? So having looked at all these works and then getting the understanding that climate has changed and most of the previous works have still not done any detailed classification, then there's the need to reevaluate the zoning and see if we can reconstruct one to reflect current climate change and variability. So if you look at our work, for example, we basically relied on rainfall and temperature. And like I mentioned, if you want to classify agro-climatic zones, you can use temperature, rainfall, relative humidity, or even solar radiation and what have you. But rainfall and temperature are quite important, and most studies elsewhere usually use rainfall and temperature. And we also relied on that because some locations, for example, can have significant ranges or wider ranges in minimum and maximum temperatures than other areas. If you pick some other locations, like for rainfall is highly variable. And so that will mean that if there are any significant changes in temperature and rainfall, then it can affect, have a very big impact on plants and animals in those areas. Then the relative humidity, for example, if you take relative humidity, basically temperature and rainfall controls it has an impact on relative humidity. So when temperature is high, you are going to have like relative humidity very low, and low temperature, you will have like high humidity. And similarly, high rainfall will mean that you are going to have high humidity. So these two factors, rainfall in a way controls relative humidity. And so even if you are not using relative humidity in the classification, you are still good to go. And temperature and rainfall could therefore be relied upon. So what we did was now to gather data. And if you look at the map here, all the dotted areas that you see are locations where we gather data. And again, I must say that most part of the country, we still don't have a dense data network as we would expect. But at least what we have here looks quite good that we could use. So if you look at like, and again, the color for those locations are just showing how much of the data that was available. And most of these data taken there are observed data, so for both temperature and rainfall. An example I showed here is just a color bar showing that of rainfall that was available. And I have similar stuff for temperature as well. So we gathered, took observed data from GMET, and the observed data was available from 1981 to 2016 daily. Actually, there were data more than from 1940 that we could use. But then from 1940 to about 1980, most of the stations had quite significant data gaps. But then from 81 to about 2016, we assured about over 90% of data available. Great. Then we also relied on the GPCC data, and that data is available from 1921 to 2016. And we had to also use that data because of the data length and because it could also help us navigate through different climate periods. Then we used CHEPS as well. CHEPS was for, so the observed data that we had between, like I said, we relied on data that was more than 90%. So, which means that the gaps that were available in the observed data, we used CHEPS to fill those gaps. And we used CHEPS because if CHEPS was built on both satellite and rain gauge data, right? Then for temperature, we relied on the error 5. Okay, we relied on error 5 as well. Now, what did we do? So to quantify our contrast in rainfall, we simply used a simple seasonality index as shown in equation 1 here. And this seasonality index was built or developed by Walsh and Lawler. And that has been used most times in some of these seasonal classifications as well. And so we just used that and did the classification for 3 climate windows. So from 1921 to 50, then 51 to 80, and then 81 to 2010. Then we did that, the classification was done year by year. And so if I now want to find the average for the whole climate period, then we used the equation 2, as you can see. Okay, so having done still on the seasonal index, we have a table here that we used to do our discriminations. So if I have a seasonal index that was that had a higher value, as you can see on the table here, it indicates that this seasonality, it indicates a departure from maybe an equal distribution of rainfall throughout the year. And 0 means that you have, for that particular area, you have like an equal distribution. So using this index, we look at areas that have similar patterns and group them together as the zones. Then for temperature, we just calculated the climatology, and it was quite easy that way, because then if you compare temperature and rainfall is highly variable, and so you will need quite a robust statistics for rainfall. And temperature using climatology was quite easy to be able to give us that picture. Then the last thing we did was to also check, after classifying, if we're able to classify all these zones, we want to check and see whether how does the wet periods and the dry periods vary. So for most of the stations that will group under one climate zone, do we have similar patterns in wet and dry months, or if we want to call it length of growing season? Okay, so to do that, we used equation 3 here for that purpose. Great. And here is just a flow diagram that is explaining all the calculations or the methodologies that were applied in order to get the new map. Good. So then this is the first results here, and talking about the rainfall regimes. So, and this was classified using both the GPCC data and then the observed data. So we start with the panel on the top on my left. That's from 1921 to 50. And so when we did the classification, you could see that the extreme northern part has a different regime. And then down that is also showing regime, a different rainfall regime. And then you will see that for also at the middle portions of the country, and then the coastal part trying to look like the northern extreme part. So we did this and moving from one climate period to another, and just trying to see what are these changes, how these changes have progressed. So you could see the starting point, those changes from the 1920 period, 1921 to 50 period. And then you can see that it's quite significant and much more clearer from 1951 to 80. And then by 81 to 2010, we can see much of a clearer picture. So then on the right, the bottom right, is similar classification, but using observed data. And if you see, again, the top part, the extreme northern ends, you see that it's depicting the same picture. And then the southern part of the northern area is also showing similar pictures, as a similar signature as the GPCC data is showing. Okay, so at least with this, all the stations that are showing similar period, we could group them together as one zone. And that's basically what we did here, as you can see. Then this is also a similar picture trying to show that of temperature, again, which was also trying in a way depict a similar picture. So now, using that information, I've kind of put the old map together with the new classification here. So if you check, the left one is showing what already exists that we've been using, and then the right one is showing the new the changes that have occurred, and then the possible demarcations that we may have. So if you look at the transition zone, for example, from the old map, you will see that much of the Guinea Savannah has taken over portions of the transition belt zone. So Kitikrachi, which used to be more like a transition zone, is now behaving like that of the Savannah area, behaving like Savannah zone. So most of the areas that you now find, only Kintampo and Wenchi kind of try to look different from the picture of the Savannah areas. And again, so the Savannah zone has kind of taken over part of the transition zone. and then also a little heading towards part of the forest belt as well. Then you can also see that the coastal area, especially from the old map, extended only to somewhere around Salt Pond. If you watch the demarcations that we've shown here, you can see that the coastal zone has now extended all the way to all parts of the coastal areas of Ghana, as we can see from here. Okay, so the left map here is our the newly proposed map that we want to show based on these results that we are seeing. Now, what's the next thing I want to take you to is trying to see, take each of these zones and see whether, when you talk about the wet and then the dry months, what their seasonalities are looking like, or the changes that are occurred. So here is for the Sudan Savannah and then the Guinea Savannah. And then the top part here are just showing the stations that are for the extreme northern end, so Nabrongo and then the Zoarongo. And then you can see that we have, so for these areas, rainy season onset only starts in May, and by September, you already have the season ending. So basically they have quite maximum about 4 to 5 months of rainfall, okay, over there. But when you move down to Guinea Savannah, areas like Tamaliwa, Ketikrachi, and Boli, for example, you would see that like the rainy season lengths are quite longer in a way. So again, even though you find that rainy season also starts for those areas somewhere in May, but then May looks wetter compared to the extreme northern ends. And then in some other locations, you also have a wet, some rains also in October compared to the extreme ends. And then when you come to stations that are a little bit closer to the forest zone or the transition, then you might have up to about 6 months, 6 to 7 months of rain. So a place like Boli, you should expect like 1, 2, 3, 4, 5, about 6 months of rainfall. Okay, so you can see that the extreme ends of the northern is slightly different compared to the Savannah area. Then here, the next one here is showing you the transition zone, and I have for the top Kintampo, Sunyani, and then Wenchi. Okay, and now there's something quite interesting here, and you will see that like what's interesting here is that you see that Kintampo and Wenchi in a way, especially Kintampo, still has like a different behavior when it comes to like the forest zone. And Sunyani is kind of picking up the attitude of that of the forest areas like Koforidua, Kumasi, and then the others. What is different for Sunyani and Wenchi is that their second rainy season are quite conspicuous. Okay, just like especially the month of September and then October. Okay, but yes, again, yeah. Now we'll look at that of the coastal area. Very good. So if you look at the coastal zones, you see that the first rainy season, the wet months are always from April to about July. Then you have the wet second rainy season somewhere in which is supposed to be like September, October, or November. Now, when you look at all these areas, they have similar characteristics. They have similar characteristics, and especially their second rainy season is not conspicuous compared to what you see in the forest zone. Great. So I'm almost done with that. And so to summarize all that I've been saying, what we are saying is that we evaluated the age-old agro-climatic zones of Ghana, and then proposed a new map for the area. And then for the new map, we're having 5 zones. So we have the Sudan Savannah, the Guinea Savannah, the transition, the forest, and then the coastal zones. Okay. Then we're also saying that if you look at this new map, that the new classification that we're sharing here, you could see that the old map has actually changed, because then you can see that the number of climatic zones are not the same anymore. Their boundary sizes or geographical orientations has also what kind of change. Yeah. And then one thing we also see is that Sudan Savannah and then the Guinea Savannah, we think that those areas are where farmers may face challenges related to adverse climatic conditions, as well as ever-changing climate environment. Okay. So this actually our work, there's actually a paper, and then I've just put there that see publication for further details. So maybe if you want to read more about all the write-up and get detailed explanations, you can check that publication for yourself. Great. So some selected references here. Most of them I didn't show them in the work, in the presentation. Yeah. So thank you very much for your attention, and I'm open to questions.
Thank you, Dr. Yamba.
And contributions.
All right. Thank you, Dr. Yamba, for the great presentation and the clarity of everything that you have really found out. We will open the floor for people to ask questions. First, we can, if you have a question, you have to raise up your hand so that we will select you, then we will allow you to talk. Yes. So in the meantime, before maybe we allow people to talk, ask their question. I have a question, Dr. Yamba. How many stations in all did you use?
Yes, please.
As observed data, how many stations in all? And I have the second question.
Yeah, they were about so they are about 60.
16. Hello?
There are about 61 stations or so. Yeah, over 60 stations.
Okay.
Can you hear me?
Yeah, I can hear you. Now also in reference to the background, or let me say the baseline climatology that you used, which of them, because you started from, okay, so what I'm trying to say is reference to
yes,
the
please.
baseline climatology. You made mention of from I think different periods. All right.
Yes, please.
Yeah, the analysis that you did pertaining to the rainfall, which baseline did you use in terms of the anomaly?
Yes. So if you look at, we started from 1921 to 1950, then 51 to 80, then 81 to 2010. Okay, so these were the baseline periods that we use.
Yes. So which of these did you use in terms of getting the anomaly for the individual station that you displayed?
We use the 81. We use the current period. So that's the 81 to 2010.
Okay. Yeah. And I also found out that Kitikachi, I think for some time now, I think that one alone has been standing out because it has a unimodal characteristic so far, because all the analysis that we have been doing, we realize that alone, when we place it amidst the savannah or the northern area, that is the only station that stands out. It looks so similar to the north. Yeah, but when you put it in this transition zone, because of its position, we see a different behavior. And I think it's also influenced by the position itself, because the Volta Lake, the way it's it looks like a Y. So the position of the Kitikachi it's been influenced by the voter league, especially from both left and then right direction. So it has a major influence over that area. It's been something that I think since 2012 we've been talking about this, and I'm happy you have come out finally to make it look clearly like the Savannah characteristic here. So thank you. I think we have Kwesi Kwegrin raising up his hands. Maybe please can you unmute yourself to talk?
Yeah, thank you so much, Mr. Moderator. Dr. Yamba, thanks for your wonderful presentation. I am so happy you've been able to do this because I happen to be one of the lead consultants on the Ghana National Adaptation Project. And before we did our work, we did some classification, trying to look at homogeneous climatic regions. And we put up a map that was eerily similar to what you've presented in your paper. And we had a very strong pushback from GMET, and lots, of course, from representatives from GMET and other stakeholders at the meeting. And they seem to disapprove, especially on the coastal front. How come the southwestern part is not unique in itself, but had joined the coastal region as a belt now? And we tend to tell them that is what the data is saying, and that is the signal we are finding. So I'm happy that you've actually put out this work. I'll share the map that we created also with you. And then you see that the only differences we have is the extent of the zones. The extent of the zones in ours is broader because we relied on ERA 5 as well as the Codex RCM simulations, which is not, of course, as close as observations as you have done. So I'm happy and thank you for this excellent work.
Dear Kwesi, please, you could share that particular image on the platform now so that the rest of us will also see. Thank you.
I'll do that. I'll do that now. Thank you.
Is to understand the impact of climate. Okay, that's the key thing here, the impact of climate, and just limiting yourself to only climate variables. But for agroecological zones, the focus is on the ecological aspect of the agricultural systems or ecological aspect. Okay, and usually when you are dealing with ecological zones, you'll be interested in things like soil characteristics or types. You can also talk about topography, you can talk about biodiversity, or you can talk about land cover in that case. Okay, so these are the things that if you want to delineate, let's say, an agroecological zone, you will be interested in. Which means that, like, if you pick an agro-climatic zone, you can have an agro-ecological zone as a subset of an agro-climatic zone. So they look alike, but their focus and definitions are different. Okay, so that's just a way of your answer to that part of it. Then your second question.
Sorry for all right. But my question was from what you just alluded to. Yeah, I was saying that from the area southwest, I mean the current tropical humid forest, all the way to the deciduous, and then towards the go area. From what you just said, you are saying they share some similar characteristics. And I was alluding to the fact that in the agroecological zone, that is reference to 205, these areas have different, mean-annual rainfall. And then there's a current data that somebody gave me, talking about the climatology from 1981 to 2020. These areas, are different in terms of their spatial and then distribution of rainfall. But from what you are saying, your work ended in 2016, and the data that is 2020 is telling a story different from this. How do you reconcile? Thinking about revisiting something, yeah.
Yeah, I get that. I get that. Now I get you. Thank you very much. I get you now. Great. So I was when I was explaining about some of these previous classifications, I think I also mentioned that if you look at GMET or the other one from my other colleague, they use total rainfall, for example. And I was explaining that usually when you are using annual total rainfall, for example, to make inferences or to do such classification, okay, you might run into trouble because then you are going to have because total rainfall will not let you see, it will mask kind of like large areas together as having like similar features. Like you will not be able to see things like seasonal contrast, or even if they are within seasonal dry spells, you will not be able to see, because total rainfall is like you are just summing everything together and using it as one value. Okay, but what is happening within seasons, you will not be able to see that. So, and that's why I was saying that maybe that methodology will not help us, or might not be too good when you're using that. Okay, now coming back to what we see, okay, you will find that the coastal areas are kind of like behaving that way. And that is because then we're able to tell the seasonal contrast, that we can say that, okay, if I take the spread of rainfall throughout the what I also mentioned was that, you see, when you accumulate rainfall, let me just share, let me share my slide again here for you to see something. Good. Perfect. Good. So this is what you were explaining. So if you see the southwestern part, for example, in terms of total rainfall, you are going to have the southwest, especially areas like Axim, having the same, having highest rainfall. And then as you move along that stretch towards Ho, you see that almost along that stretch is having higher rainfall, just like you find in Axim. And it cuts across the, what do they call it? The forest belt all the way towards Volta region and then into Ho, as you can see from here. Now, one thing we are not separating from it is that you will see that along that stretch, you have this Togo Equapim mountain ranges. And we know that these physical characteristics or physical features also have an influence on rainfall. Okay, also have rainfall an influence. So then I was asking a provocative questions like, for example, if we want to get a clearer picture, then we will need to separate the influence of these physical features, their influence, from our normal monsoon rainfall. So if you look at like all this classification that we've done, it's giving us a picture of what the normal year-to-year monsoon rainfall classifications picture is going to look like. And so we're going to have that that's working. But because you are going to have this kind of mountainous regions effect also there, it's kind of like also making the rainfall along that stretch also high. So for me, I think that it's also bringing much more questions for us to go into detail and trying to determine what the contributions are from these two effects, the normal monsoon rains and then the these environmental features like these mountainous areas, for example. Right. Otherwise, if it is just from our normal monsoon rainfall, then what we are doing is correct.
Hello.
I hope I've. Yes, please.
Hello.
Yeah. Hello. I think since we finished with Bimpong, Nathaniel, we can now allow Ismail Abdul Fattah to also have his question. He has his hands raised. So, Mr. Ismail, can you ask a question?
Okay. Thank you for a very beautiful presentation. I'm from the Department of Agric in Kumbungo, and as an agriculture,
I wanted to show you this map.
I'm looking at how this new classification would help me in my extension delivery. So looking at the new classification and taking into consideration temperature and rainfall, that means that at every given, at this current classification, the agroecology is different. Hello.
Please, someone on the floor.
Yes,
Yes, I am.
Nathaniel, someone is on the floor. Well, let me finish.
Okay.
Yes, all right. Mr. Fatah, can you
So
continue?
okay. So I was saying that looking at this new classification, that means at every area of this classification, temperature and rainfall would affect the agroecological zone. So what we are used to would have to change. For example, I'm in Kumbongo, and at this point in time, we've started sowing. So that means that if this new classification we are to go by it, that means that we have to consider our temperature and rainfall. So that means that our ecology has changed over the period of this paper. So now I have two questions. I don't know whether to be suitable for Dr. Yemba or Jimmy. How will this current classification help our farmers looking at this temperature and rainfall since both factors affect crop production? And this one will go directly to Jimmy. I don't know how GMET can organize similar meetings targeting departments of agriculture because we are from different endeavors. I'm looking at how can they organize similar one to affect this new classification. For example, I believe that I will be within the Guinea Savannah area. How can they target us to sensitize us more on this new classification, taking into fact temperature and rainfall, because these factors will definitely affect our agroecological zone. Thank you.
Okay, so I just give some response and then maybe GMET may come in. And so talking about the impact, for me, this has a very great impact, especially in terms of rainfall, the length of rainfall season, the amount, and also the interseason variability that we have, that we experience. And one other effect is also is that there's much significant impact on the, especially the onsets in the rainy season, and then also the cessation. Okay, now, like I showed some plots here also that we are doing some other work here where we have already seen that rainfall in the northern region, for example, is highly variable and is becoming too difficult to predict, especially when it comes to the onsets and then the cessation. So, and it's all because of this, the impact of climate change and how it has affected all these climatic zones. So temperatures, rainfall at the moment in these areas are having significant impact. And for me, it makes sense that we get to educating our farmers more on this. And GMET will also have to now think about their forecasting and how these information, like we can get to farmers and begin to educate them. Another proposal that I think that we should also get into is also trying to now begin to look at how to reclassify the various agroecological zones, because then if the climatic zones, because definitely, like I was mentioning, climatic zones have impact, will definitely have an impact on agroecological zones. And if that is the case, then, because for example, if you're using something like land cover as a way of classifying an agroecological zones, most of these things have already changed. And that will mean that we'll have to also begin to think of this area and seeing how we can do this robust classification again for better agricultural purposes.
All right. So Dr. Yamba, I think yeah, in answering the GMET question, um, Mr. Fatau was interested in how GMET can sensitize I think institutions within that area which have seen new change, according to the classification that you have made. Mr. Fatau, am I right on your question?
Yes, please. Especially targeting departments of agriculture. Yes.
Yeah, I think it's a very good question, and this particular classification we are seeing right now is something that we are going to also consider, because as an institution, based on this this type of researches really make us more, it gives us a better foundation on how to even organize ourselves very well. So In terms of sensitization, it can be now put into consideration, organizing various workshops, especially within these areas that these classifications have been made. It's a very good action which we can chance on. So it's going to be put into discussion, and then I think the necessary actions are going to be taken accordingly. Hello. Okay, so maybe we'll move on to the next question. I think there is a hand raised, but the name is AA. Please, if you could unmute yourself, it would be nice if we can see the right the name, because AA is not so clear.
All right, thank you very much. Good morning, everyone, and thank Dr. Yamba for the presentation. The AA is Afia Atiobe. So, okay, please, by your explanation, you said that it is clear that there is difference between agro-climatic zone and agroecological zone. But I was expecting that your result should come out with an agro-climatic zone because of the variable that you use for the modeling. So, but you present the old ecological zone versus the new ecological zone. So I'm a bit confused because since you have used a climatic variable without having any input of soil characteristic or either biodiversity or not. So why should we call it an agroecological zone? Thank you very much.
All right, thank you very much. I think what we have here is not agroecological zone, but agro-climatic zone. That's what I have here. So our work is not, maybe if you heard me talk about agroecological zone, I was only giving an explanation and all the differences. But then if you look at what we did here, our work is, we should call that agro-climatic zone and not agroecological zone. The other thing I want to add to is that if you look at like the classification that already previously existed, sometimes we confused ourselves and we usually called it agroecological zone. Okay, and I've seen like some works that we've referred to those maps as agroecological zones. They were not classified using soil types and characteristics or land cover or biodiversity or something like that. So all that was already existing was agro-climatic zone and not agroecological zone. So what we have is agro-climatic zone, not ecological zone. I hope I answered you.
So if I think you heard it. I don't know whether you are okay with it.
Yes, thank you. I'm okay. Because of on the slides, it was agroecological zone. This is why I was a bit confused. Thank you.
Oh, okay. All right. I think nobody has raised their hands now. So it means that everybody is satisfied with the presentation. Oh, okay. I think there is a question. Okay, let me check into the chat. Yeah, I've been just drawn, my attention has been drawn to the fact that there have been some questions in the chat. Okay. Somebody is asking, I learned southern part of Ghana has bimodal rainfall. So since coastline zone is behaving more like or less like the Savannah zone, can we reconstruct that statement? It's coming from Ralph, our tremendous. Okay, so can Dr. Yamba?
Okay, so yeah, so the thing is that let me see, say Alan Saudi. Well, but okay, so I'm not able to understand from where to where the person is referring to as a southern Ghana. But if you look at from our classification, maybe the forest zone all the way to the coastal areas can be referred to as a southern Ghana, if I get that point. So then from the forest zone to the coastal areas, all of them still have bimodal rainfall. The thing is that the coastal areas, their second rainy season is not as conspicuous as you can find in the what do they call it? As you can find in the forest area or the forest zone. Okay, and if we also say that it's behaving like the coastal area is now behaving like the savannah. Okay, that's also because maybe we're trying to make an assertion that the second rainy season is not any, let me be careful with my words here, like it's not too conspicuous, or maybe it's too variable. Because if you see most of the plots that I showed, for example, forest belts, you can have rainy season starting from the second rainy season starting from September, October, September, October, that way, and maybe partly November or so. But when you go to the coastal areas, mostly you might see maybe like only October, and sometimes September is dry. Some areas September is slightly wet, or you have like only October showing conspicuous rain, and then the rest of the other months are either dry or maybe just slight rainfall. Okay, so you would find that their second rainy season is highly variable, and so much of the rainfall you would see would be from only the first rainy season. Okay, and maybe so if we make that statement is because we are seeing much rainfall only in the first rainy season, as you see in the Savannah zone, and the second rainy season is almost quite highly variable. So for now, I'm not sure I have the authority to maybe I am the authority to suggest whether we can rephrase that or not, but that authority is vested in Ghana Meteorological Agency for them to decide what we can do.
Yeah, thank you, Dr. Yamba. I hope Raphael is okay with this answer. I hope the person is okay with the answer. Yes. So okay, I think we have Mendo Obed, who has raised up his hand. Yeah. So Nathaniel, we'll come to you later. Let's finish with Mendo. Can you unmute yourself to ask your questions?
Thank you very much, Mr. Host. Really, I came in late. I couldn't get the presentation. I just missed it out completely. So I wanted to find out if there's a way of getting any materials on the presentation so we can go through it.
Sure, you will get it. You'll get it. We will send the video recorded version of it, and then also the presentation material to you, so you have access to it. Yeah.
I'm very grateful, sir.
All right. And then Nathaniel, was it an old hand or it was a new hand? Yeah. Hello, Nathaniel.
Hello, sir.
Yeah. Was it an old hand or a new hand?
Oh, it was a new because I have to come back again for another question. Then probably.
Okay. All right. Please continue with your question.
All right. So please, I want to find out, senior, why you chose 1981 to 2010. You know, when we know that for decades an area, you know, that ceased to revise, you know, would have also undergone significant changes. A work that I kind of read about Yanzi et al. In China, when they were also trying to do decadal, you know, trends in looking at how agro zones or agro-climatic zones change. But your analysis ended in 2010. In fact, if I look at the map, the very year you used was the 2010. Why? From 2010 to this time, a decade is too much. And then my last question is, you are saying you used stations, 60 something, but I believe that in Ghana, GMET has officially, 22 stations. So if somebody is doing a work like this, that has these 32 stations, are we saying is not robust? And then the last one is that I'm not seeing the interzonal variabilities that we hope to see, to say that this zone, though the ocean characteristics, the interzonal disparities are not still seen. How do we address that in the future? Thank you.
Okay, Dr. Yamba, before you come in, just a correction. I think the statement made by what's the name? Nathaniel is GMET is officially having 22. No, we have 22 safety stations. We have other stations which are also agro and then climo, and we also have rainfall stations. So it's not just 22. We have over 160 stations over. It's high.
I was saying that, no, I was just trying to say, if somebody is doing a work that has the 22, right, is that work also not, robust enough? That's what I'm trying to, I guess, suggest, not to say you only have those stations. Thank you.
Okay. Dr. Yamba, please, could you come in?
Okay, so I think that okay, I just pick it up from this last part. I don't know, maybe saying robust could be relative, but in terms of, if I'm going to use talk about whether it is robust or not in this regard using station network, then if I have results from work that is using more dense station network, and then another work that is using kind of like sparse station network, and looking at, given the fact that rainfall varies has a very high variability. So for example, if I take like a 5 kilometer away or a 10 kilometer away, rainfall will vary, but vary, and not even talk about like a 10 kilometer away. So if you use GMET station dense network, which I think I showed in one of the works, for example, where in the northern part of the country, for example, you have about 5 stations. Now, most of these stations are already over 50 kilometers away, but rainfall can vary from a very short distance, like 5 kilometers. So if you have like station network that is using about more than over 50 kilometers and to produce such a work, and someone is using something that is more dense, and giving with that idea that rainfall can vary at very short distances, then I think that you would understand what that means in this case. So I think I've answered you from that aspect. Then coming back to the what is it, the period you talked about, the fact that the work ended in 2010, and yes, it happened that way because then we were following the climate-based periods. And if you find out from, in fact, like Ghana Meteorological Agency usually have like defined climate-based periods that we have to follow, especially when you are doing these classifications. And secondly, we also say that if you have to have such kind of classifications, at least you need at least a 30-year period. Okay, even though within some maybe decades, as you were mentioning, you can have this kind of changes. But then what is much more required is if you have a 30-year period, that should give you a quite good climate window. And climate, GMET defines also that. And so all the base periods that I think GMET uses, or even what they use also for this IPCC, I think the IPCC people also use that same climate period window. Okay. So, but then the classification started all the way from 2021 down there. And the whole idea was to see how the changes have progressed. Because then right now we are almost, we are still in this same climate window, and very soon we will migrate or we'll move out of that climate window. And I think the next window should extend to I think 2020 or is it 2020? I don't remember.
Yes,
Which would mean
the new normal is now from 1991 to 2020.
perfect. So the new normal will now be that. Good.
Yes. So
which means that.
Okay, continue.
Yeah. Please finish it up.
Yeah. So I'm just saying that even this work that you have done, it would be very good to update it right now using the new normal. That's from 1981 to 2020. Yeah, because that will even make it more.
Yes. So that's where I was just coming, trying to land and trying to say that when you look at these things, for example, so if we're going to be following these climate windows, it means that for each climate period, we will have to be updating these agro-climatic zones frequently. So which means that this particular one like this will need data like to get it updated to now suit the new normal that we have. And once we are moving out of it, we will have to update it again. So this should be something that we'll frequently have to be updating, and then also updating farmers frequently on it.
Yeah, thank you. I think we have a last question because of our time. So we would ask Mr. Patrick Imbo to just quickly unmute yourself and then ask a question so that we can bring our session to an end. So, Mr. Patrick, can you unmute yourself? Hello? Mr. Imbo, can you unmute yourself? Yeah, it seems he cannot hear us. So,
hello?
Yeah, okay.
Hello?
Yeah.
Can you hear me?
Yes.
Okay, thank you so much for giving me this opportunity. But I thank Dr. Edmond Yamba for this wonderful presentation. 2 questions. Can you hear me? Hello, can you hear me?
Yes, please, we can hear you.
Okay, that's fine. I have 2 questions. And the first one is, are there any opportunities or new agricultural practices emerging as a result of these changing agro-climatic zones in Ghana? And the second one is, what can an individual do to contribute to mitigate the effect of these changing agro-climatic zones in Ghana? So these are my 2 questions that I want to find out, if there are any. Thank you.
Okay, yeah, thank you very much, Patrick. And great. So one is opportunities, and then the second one is what an individual can do. In terms of opportunities, I don't really know. I'm not aware of any opportunities at the moment, but I feel that, you see, we do the science, and then we have to get it communicated to those who uses it. And like I said, I think GMET would have to take up this, because they should own it. It should be their work, and they should own it. And then that will now help them, especially in their forecast and what have you. And this is how, as they educate people or make forecasts from this works, for example, a lot of people will begin to benefit, especially farmers, and that can help them. And then maybe agricultural extension officers and other people, other stakeholders who this is much more relevant to, can also now use that information to educate the people that they work with, especially in the field. So maybe this is how people may benefit from it. But coming to talk about what an individual can contribute also, as for the effects of climate change, is become like an important topic that all of us have to. And if we already know what the impact of the climate changes are, then it means that all of us individually will have to play our role from that point. So if you look at like some of the what might be contributing to these changes, for example, one is the climate change that we're talking about, but then anthropogenic climate change is also something that is playing a bigger role in this case here. So as to how we can combat if you have to play a role, then you have to think of how we can slow down anthropogenic activities or climate change in this regard. So maybe if someone has like a better response, that will be fine. But this is what I have to say for now.
All right, thank you so
Thank you,
much.
Doc.
Yeah, thank you so much, Dr. Yamba, for the great work. In fact, you have really made us very happy, and then we are now understand a lot of things. On behalf of GMED, it's an opportunity for us to also send more information to or educate our various stakeholders on this new development, because it's a very good work which we can use to also help people understand what is really happening currently on the within our jurisdiction as a country. Okay, so we have to bring our session to an end, and thank you again, Dr. Yamba, for availing yourself to even be part of this particular drive to educate more of our stakeholders. And we need to take a picture of all participants. So please, I'll be happy you can turn on your video, even as we prepare to take a snapshot of our very astute participants. Everybody, we really appreciate you. Please turn on your video. We want to see your face so that we can use it for our, for our archives. So kindly turn on your video as we even take the picture together. Yeah, I can see. Yeah, I can see Dr. Yamba has a lot of students who have really appreciated what he has done. So they are calling him here. Okay, so everybody, let's take the picture. Are you ready? 1, 2, 3. All right, let's take the second one, the second shot. The second shot. Okay. 1, 2, 3. Yes. So we are so grateful for everyone. We are going to send a video, the recorded version of this video, and then also the PPT for the presentation. Yes, so that we can, at least if you have any questions, he has his email also on his PPT where you can easily link up and then ask the necessary questions you are really bothered with. So on behalf of every participant, Dr. Yamba, we are so grateful for your time. And then we believe in the future when we call upon you again, you'll be available for us and even come up with more recent publications that you have made. Thank you so much.
There we go. So,
Thank you very much.
Dr. Yamba, you when we started the meeting, you didn't mention my name. You rather used a different name. So please correct yourself.
Oh, okay. Sorry. Apology. I'm sorry, my boss.
All right.
Dr. Yamba.
Yes, please.
Dr. Yamba. Yeah,
yes, I'm here.
I want to have a chat with you. I want to have a chat with you later.
You want to do it?
Yeah, I want to have a chat with you later. You know.
No problem. No problem.
Yeah.
I'll do that. Yeah.
All right.
Hey, Amma.
Okay.
All right. Bye to everyone now.
Okay, bye.
Bye.